I'm going to post a video to clear up a couple of things I've seen people confusing on some of these practical applications problems, and then we had a couple questions on it itself as well. So what we're going to be looking at is number 13, and you have this diagram here. Hopefully it showed up for everybody. I had to send it out to a couple people that weren't able to see it on their computer. But we're looking at this diagram here, and then the problem itself is number 13, where it says find the missing dimension D in the 5/16 inch flathead screw shown. So I want to make a couple observations on this before we solve it. I see a lot of people doing trig problems wrong because they are misinterpreting how to look at these drawings. When you see a dimension like this, they're not telling you that this angle, this hypotenuse, is 0.1831 here. They're telling you that from this distance to this distance, right here, is that distance. Really what they're saying is that's this distance down here. They just can't write it in there because they don't have enough room. So you're going to see this in a lot of drawings, whereas they'll just carry a straight line parallel to some other line down here like they have, and they're going to show you that distance, and then they'll give you the number like they did in this case is between those two. Now, when you have this angle here, they're not telling you that that angle is what is that distance. They're telling you just this line to this line straight across is this number. If they were to be talking about this line here, instead of having it like this, they would have it oriented like this. And they don't. So that you don't know what that hypotenuse is of that triangle. You don't know what that angle is. The only thing you do know is the distance between those two lines, which are completely in line with these lower dimensions. Just this distance here is this number. So to simplify it, we're pretty much just saying that's not the hypotenuse, that's the base of that right triangle in this drawing. So that being said, and with that understanding, we'll talk about this angle here. So the 82 degrees. This 82 degrees is kind of the same idea. It's just from this line here to this line here. And that line could start way back here and come out as far as you want, and that angle would never change. That angle out here is 82 degrees, and then if those 2 points came to a point here, that angle right here is 82 degrees. Now with that in mind, even if these two triangles here were butted all the way up and this whole middle section was taken away and we just had two right triangles, that angle would still be 82 degrees. Now, since we have a base of 0.1831, the most useful thing to do with this triangle is going to just be apply that to the base and use part of that angle as the viewpoint for our sine, cosine, or tangent. So if we're only going to be looking at this triangle I'm shading in right here initially, because we want to find dimension D, this is part of it, this opposite side of our angle. So if we find that and that down here, both those, we can then add in this 0.3125 dimension. So let's backtrack to the beginning of the problem and kind of look at where we're going to start with that explanation first. So if I have this right triangle right here, and I know that from this line here, half of that original angle, 82, because I'm only looking at one of the right triangles, is going to be right here, is going to be 41 degrees. Based on this part, I know down below 1831 inches is my base. And what would help me solve this equation would be to find out in this right triangle my opposite. So if I have this as my perspective and I need to find this side, that's my opposite side, and I have a known adjacent value, not a hypotenuse, I have opposite and adjacent, so I'm going to be looking at tangent. tangent 41 degrees equals my unknown opposite side divided by 0.1831. So if I cancel out that 0.1831 by multiplying both sides, I get 0.1831 times tangent 41, and that's going to give me my opposite. So let's see what that is in our scientific calculator. 0.1831 tangent 41 degrees gives me 0.15916. So 0.159, we'll just stop it there, inches rounded. Multiply that by 2, because I have 2 right triangles, right? And I already know this dimension. So I have here and here so far as 0.3125 and my 0.159 on top and on bottom. I'm going to add all of those together. And get 0.6308, so 0.631 inches. So with this side here, this already given value here, and then adding a second right triangle side here, my overall dimension D is going to equal 0.630832, or 0.631 inches. So that was a little bit of a messy one, but if you understand how to read the drawings properly, that's going to get you off started on the right foot. So if you have any questions on any other ones, I'd be happy to post some more. I'm going to continue recording tomorrow's lecture since we're going to be getting into some more detailed stuff with vectors. I'm going to follow up your reading with a kind of a review, a lecture on it like we did on the last combination circuit sections. So let me know.